Parametric equations. Why we are interested in using parametric equations? First of all, it gives us flexibility. Parametric equations provide a flexible way to represent shapes that cannot be described easily with a single equation. Sometimes writing equations using parametric equations makes the computation easier. It makes it easier, for example, to compute the derivatives and integrals for curve, calculate the length of curve, and so on. They also offer a clear way to describe motion and paths, which is particularly useful in physics and engineering. Parametric equations have the form x, which is described as a function of parameter t, and y, which is a function of t, which is denoted by g of t. So both of these x and y depends on t. F and g are given functions, and the parameter t typically varies over a specific interval. For example, you can write t bounded between a and b inclusive. The parametric curve described by these equations consists of points in the plane x and y is basically f of t and g of t. So they are changing as t is changing. You can assume t is time and the position of the object is changing as the time changes. And t is bounded between two values a and b. X is f of t again, and y is g of t. The standard two-variable description is x is mapped to y by function f, but now that we are using parametric equations, it is basically assuming you have a new parameter, which we denote by t. T is mapped by f and also g. So x is equal to f of t and y is equal to g of t. Again, you can assume t is time or temperature or angle, depending on the context of the question. Parametric parabola. How do we graph a parametric parabola given by x, which is f of t, equals to 2t, and y is g of t, which is a half t squared minus 4. And the question said, assume t is bounded between 0 and 8 inclusive. Let us begin, everybody. We're going to form a table. We're going to start by giving values to t and calculate x, calculate y, and then in Cartesian plane, we're going to plot xy. So when t is equal to 0, your x becomes 0. Because x is equal to 2 times t, and when t is equal to 0, you get 0 back. What about y value? Y is a half 0 squared minus 4, so you get negative 4 back. So the very first point is located at 0 and negative 4. This point is on the graph of this curve. So when t is equal to 0, you have 0 and negative 4, which is located down here. Suppose t is equal to 1. So x becomes 2, and y becomes negative 7 over 2. You have 2 and negative 7 half, which is your second point. So from the first point, you get to the second point. Then assume t is equal to 2, x becomes 4, and y becomes negative 2. So the third point on the graph is 4 and negative 2. which is basically just this point here. When t is equal to 2, x is 4, and y is -2. When t is equal to 3, x becomes 6, and y is a half. This is simple algebra. You plug in 3 here, 9/2, minus 4, which is a half. So you have the 4th point, 6.5, on the graph of your curve. Next point, t is equal to 4. X becomes 8 because it is 2 times t, and y is 4. So a half, 4 squared, minus 4 is 4. So next point is 8 and 4. And as you can see, this is your next point down here. And as you can see, the graph is increasing graph. The next point, 5. When t is equal to 5, your x becomes 10, and your y becomes 17 divided by 2. So this point is 10 and 17/2. Next t is 6. X becomes 2 times 6, which is 12, and y is 14. So next point in Cartesian plane is 12 and 14. When t is equal to 7, your x is 14, and your y becomes 41 divided by 2. So you have 14 and 41 divided by 2 on the graph of your curve. And finally, since t stops at 8, the next t value is 8. So your x becomes 16 and y is 28. So this point is 16 and 28, which is, as you can see, on the graph of this curve. So this is this piece of curve. When t is bounded between 0 and 8, you have this piece of curve here. Now I expect you to ask how to eliminate t. Well, since x is equal to f of t, or 2t, and y is g of t, which is a half t squared minus 4, from the first equation, you can isolate t. X is 2t, so t is nothing but a half x. We're going to substitute this into y equation. Y is a half t squared minus 4. So you get a half times a half x to the second minus 2. It means that wherever you see t, you're going to use a half x. Well, this is basically y equals to 1/8 x squared minus 4. Or this is basically the parabola that you learned in algebra. When t is equal to 0, your x is equal to 0, and y becomes -4. This is basically the starting point. And you can plug in different values for t. So when t is equal to 8, x is equal to 16, then you plug it into your y value and you find the stopping point on the curve. So that's how you can eliminate t, or the parameter, and visualize the xy relation in xy plane. So you either use the table that I showed you in previous example, or sometimes it's easy to get rid of parameter t or parameter s or any other parameter and basically write the equation that is familiar to you and you saw it before. 1/8 x squared minus 4 is a quadratic equation that you already know how to graph. A positive orientation is the direction in which a parametric curve is generated as the parameter increases. And as I mentioned, it is called the positive orientation of the curve. It's indicated by arrows on the curve. The parametric equation of a line is described as x, which is x sub 0, plus 80, y is y sub 0 plus bt, and t is bounded between negative infinity to infinity. X sub 0, y sub 0, a and b are constants. A is non-zero, and it describes a line with slope b over a, passing through the point x sub 0, y sub 0, and if a is equal to 0 and b is non-zero, then this is basically a vertical line.